Good evening, everyone. It's my pleasure to welcome you to this evening's presentation. I say this evening because I'm here in Cambridge, Massachusetts. I know it's afternoon there in California, but welcome to the Quarry Lane InvenTeams Mid-Grant Technical Review. My name is Lee Estabrook, and I often say that I have the best job in the whole world as the Invention Education Officer with the Lemelson-MIT program. I'm joined tonight with Tony Perry, also with the Lemelson-MIT program. Tony leads InvenTeams day to day, and he's been working with this team since October. Very, very pleased to have Tony with us, of course. And I'd also like to say a special thank you and give a shout out to Anthony and Genevieve for being our ASL interpreters for this evening. I am often amazed, surprised, and uplifted by the work that our InvenTeams do. When the application came in for the Quarry Lane InvenTeam, I have to say that it was one of those applications when I read it, I just sat back and said, but of course, this is a real world problem that needs to be solved. I'm really looking forward to hearing from the students tonight. And I know that they're going to really kind of impress us. However, our team will be looking to you, the audience, to provide them feedback throughout this evening. So at this point, I'd like to hand it over to their teacher, Richard Ong, who is going to say a welcome also, and then turn it over to the students. So Richard.
Hello and good evening, ladies and gentlemen. Thank you so much for taking some time out of your evening to spend with us. I would like to extend a special welcome to our community partners, Ms. Ayers from the California School for the Deaf and Ms. Martinez of Camp Pacifica, who have guided us from the very beginning of our journey. I would also like to recognize the Lemelson-MIT program and the Quarry Lane School for making all of this happen. Of course, I would also like to thank all of the students, their families, and all of the friends that are here with us tonight. My name is Richard, and I am one of the mentors for the Quarry Lane InvenTeam. Although at this point, I should be getting used to introducing myself as Mr. Ong. Our other two educator mentors are Ms. Lang and Ms. Shin. They are somewhere in the crowd also wearing one of these fancy blue InvenTeams polos. This year has undoubtedly been a remarkable one. Unfortunately, as we reflect upon these times, it will be remarkable for so many negative reasons. But within all of that tragedy, it has also been remarkable for some pretty amazing achievements, some of which include our students, their perseverance, and determination to continually improve themselves and their communities. It would have been really easy to just say that this year had way too many things going on, to close in and just focus on getting by. However, our students wanted to do more, so they did. Since the beginning of last summer, our Quarry Lane InvenTeam students have been busy researching social issues, bridging community partners, zooming through endless meetings, tinkering with numerous gadgets, and turning ideas into inventions. Along the way, they have learned to overcome so many challenges by relying and depending on one another as a team, seeing the value of working with one another as opposed to just for themselves. It continues to astound me whenever I remember how young these young people are because of how much they have achieved and will continue to achieve. It is quite remarkable. By this point, it should be fairly evident of how proud I am of our students for all the things they have done and for being who they are. They have heard me say it plenty of times before, but I will say it again, because they always manage to find new ways to inspire me as a teacher, as a citizen, and just as a person. So without further ado, I present the Quarry Lane InvenTeam.
Hey, and welcome all. My name is Priya, as you can see by my name tag. And today I'll be introducing kind of a bit of background about our team at first and kind of explain, what this whole InvenTeams initiative is. So we've already been tossing around the term InvenTeams a lot. So here's a bit of background. Our team is one in 13 of this nationwide InvenTeams initiative, which is an organization dedicated to nurturing creativity, innovation, and engineering by supporting high school teams like us. As one of the selected teams, we've been given a grant by the Lemelson-MIT program to develop an invention that tackles an issue within our community. Our ultimate goal by the end of the project is to display a final prototype in the Eureka Fest in June, so stay tuned for that. We sent out a bit of a short poll just to kind of figure out, who's here, who's checking us out. So, as you know, our team is composed of high school students from the Quarry Lane School in Dublin, California. Right now, I'm just going to run down the list and introduce each person on the team. So if you could just wave when I say your name. So we have Bridget, Christine, Bryson, Isha, Harini, Krithik, Rachel, Varshini, and of course myself. And if there's any fellow students out in the audience, then you might recognize a few names or recognize a few friends. And of course, we don't want to forget our mentors who have been supporting us this whole time, Mr. Ong, Ms. Lang, and Ms. Shin. So thank you so much for your support this whole time. So a bit about our story. Our team kind of started out with us, your typical high school students who came together for the first time under a shared passion for engineering. And even at that point, we had no clue what community issue we would take on. But after a few weeks of chatting and getting to know each other, we discovered a second common interest: sports. And it was these two shared passions, engineering and sports, that led us to the objective we wanted to address. So Bridget, if you take it away.
Hello, my name is Bridget. So getting straight to the point, the community issue we identified was that basketball players with hearing loss have no way of responding to referee whistle that they are unable to hear. While hearing loss has no impact on athletic ability, it does impact the flow of the overall game. For example, if a player doesn't notice when the whistle sounds, then the team loses vital seconds in setting up their next play. This also impacts the team's strategy when the coach is trying to tell the team to run a play but can't get the player's attention. Our team's goal is to reduce these communication delays by improving players' reaction time to a referee's whistle. Our intended users are deaf basketball players in particular, but depending on later timelines, we would love to tailor our invention to other sports as well. Additionally, we aim to create multiple devices that accommodate for a larger team. This target audience was important to establish early on because during our research phase, we focused primarily on interviewing people in the deaf community. We wanted to understand their point of view as deeply as possible to adjust our project accordingly. The first interview with Ms. Ayers, a hearing coach currently at the California School for the Deaf. She stated that she has tried various methods to get the player's attention, including stomping on the ground to send vibrations and waving her arms while running up the sidelines. While this often had some success in grabbing the athlete's attention, they were not practical at the fast pace that basketball games run at. Ms. Martinez, the director of the Deaf Camp of Pacifica, pointed out this issue's appearance across a wider range of sports. Runners sometimes started late because they couldn't hear the starting whistle, and in football, those coaches used drums to send vibrations across the field. She suggested the idea of a haptic device, which, as you will see later, we are using as our functional idea.
Hi, I'm Isha. So now, in terms of our solution, after further research and interviews with the community, we came to the solution of alerting a deaf basketball player through other senses, namely a haptic vibration. Our device will basically integrate the referee's whistle so that when the whistle is activated, the device will send a wireless signal, causing the player's wearable device to vibrate. This vibration can communicate specific messages like a dead ball or even a coach's instructions. Now, in terms of design criteria, it should be safe, of course. It must be comfortable so it doesn't get in the way of the game. It should be physically located in an unobstructed location, and we're currently leaning towards it being located on the ankle. It should be efficient, it should be durable, and it also should be ergonomic. And finally, it should be policy permitted. And we'll go a little bit over what policy permitted means in another subgroup. Now, in order to set a goal for our device, we did some initial testing to find the current reaction time of deaf athletes. By watching basketball game footage, we determined that the average reaction time was around 2.5 seconds. This set a benchmark that our device must improve from. All right, now let's talk about our physical prototype. In this section, we're only showing our latest device. Later on, when our subgroups present, they'll elaborate more on the development process and the evolution of this device.
Hi, my name is Harini. Here's a quick breakdown of how our system works. Our system has 3 defining parts. First, the referee is using an electronic whistle, where they press a button to emit a loud sound instead of blowing it. For our project, this whistle is modified to wirelessly send a signal to the player's device when pressed. When the player-worn device receives the signal, it will then vibrate using a vibration motor to notify the player of the referee's call. Here's a video of our latest prototype in action. The vibration motor is placed on top of a box to make sure its vibration is easier to see. In the video, the button will be pressed to trigger a vibration. An on and off switch will also be demonstrated. Apologies in advance for any audio delays caused by lag. For the wearable haptic device, we made the electronics as small as possible by using an Arduino Nano and a small radio transceiver and soldering them together. Here you can see some of the components labeled in the diagram. The electronic setup is still in its prototype stage, but we've still added features like a rechargeable battery that charges with USB-C, visible on the leftmost side of the diagram. This is our most recent trigger device prototype. which is enclosed in laser-cut acrylic housing. As you can see, we made a custom electronic whistle by attaching a buzzer component that makes a whistle sound when the button is pressed. We also added the feature of an easily accessible on and off switch. All of these features are labeled in the picture. Because of new requirements and guidelines due to the COVID-19 pandemic, most referees are now using electronic whistles instead of traditional ones. This allows our devices and system to be used without creating a drastic change for the referees. Currently, we are using radio transmission as our connectivity method because this system allows us to connect multiple receivers and multiple transmitters. This means we can accommodate an entire team as well as multiple referees and coaches. In this video, we're demonstrating how the signal works perfectly at a distance of up to 35 feet. So the total range claims to be 100 meters or 300 feet, which should be more than enough to cover the length of a basketball court. With our first full prototype, we took some data on how fast the reaction time was. As you can see, we conducted 10 trials, and the average reaction time is 0.62 seconds, which is much lower than the previous 2.5 seconds without the device. The results are already incredibly promising, and this is only our first prototype version.
Hello, my name is Varshni. Moving forward, we hope to begin physical testing of our device in mid-March or April, working with our partners Deaf Camp Pacifica and/or California School for the Deaf. Regarding our invention, our next steps include making the device more durable and compact, adding multiplayer capabilities, and adding an option for the coach to control the player's vibration. We would also like to acknowledge and thank Deaf Camp Pacifica, California School for the Deaf in Fremont, the Quarry Lane School, and of course, the Lemelson-MIT program for providing us with this opportunity. Without them, we wouldn't be here at all. Can we get a hand for them? A clapping emoji works too.
Hi, I'm Bryson. Now we'll have a question and answer session. While we're doing that, we will have a feedback survey, and we'd appreciate it so much if you could fill it out. Anyone is welcome to complete it, regardless of knowledge or experience. If preferred, you can choose to fill it out anonymously. With that said, we are now taking questions, so please ask any questions or comments, and feedbacks are also welcome.
Okay, so we have a question. How do you plan to test this with your outreach partners? So essentially when COVID guidelines let up a little, we do hope to meet with some of the students at the California School for the Deaf or from Deaf Camp Pacifica and give them our product and have them test how it works in play, as well as some reaction times.
So, how is your spending and budgeting changing due to the COVID restrictions? I'm going to give that question to Christine. Do you want to take that away, Christine?
Oh, wait, can you repeat the question?
Oh, sorry. How has your spending and budgeting changed due to the COVID restrictions?
So right now, we basically, due to the COVID-19, basically kind of work at home and then to basically like testing by ourselves. And we cannot really get like the feedback or from the others, but we usually kind of like interview others to get like feedback from like what we need. And based on that to improve like our product.
Okay. So another question is, are you in contact with deaf sports players to test this product? We are in contact with our 2 outreach partners, and they are basically they're like coaches at their school. So we're hoping to basically give those products to these outreach partners and be there to test it with them, obviously respecting social distancing rules, but that's our best case scenario. We want to actually be there to test the reaction time and how are things really working with this device. So yes, we are in contact with those outreach partners, but we've not really asked the specific students there yet because, yeah. Okay, another question. How did you test this reaction time with the device? Karina, do you want to take that question?
Sure. So pretty much because we haven't been able to meet with any outreach partners yet due to COVID, we've mostly been testing, our team members have been testing by, wearing the device and having a helper trigger the device from a distance far enough that we can't actually hear the whistle. And then we just like raise our hand and with a stopwatch we kind of measure how much time it took since the person pressed the whistle and the player felt the vibration.
Cool. Okay, another question is if there are multiple players, how will the coach or referee send unique signals to each, or will all the players with this device receive the same signals each time? So, Rachel, do you want to take that away?
Yeah. So right now we currently only have one transmitter that will trigger one single type of device, one single type of feedback or pattern. However, as later on, we will consider adding on a coach control, and also we'll consider adding on a different pattern and a different trigger device. And it will be further discussed in the subgroups presentations.
Okay, great. And another question is, what's your criteria for whether your product is more effective on someone? Does your criteria change based on the sport? So I'll take that question. So currently we are working towards having this targeted to basketball players, but we're hoping when we expand our device further, we might target it to more sports. So basically our effectiveness of that product will be measured by if it's beating that reaction time of about 2 to 3 seconds. Also, is it matching what we want it to be in the design criteria section? So that's going to basically be how we're going to measure that effectiveness for the product. Is it comfortable? Is it really doing what it's supposed to? Is it beating that goal of the reaction time? Is it helping them, right? It shouldn't be something that is distracting them from the game. So that's going to be how we're going to determine the effectiveness of this device. Another question, any safety concerns with sweat and impact on the electronics? Kritik, do you want to answer that question?
Sure. So for any safety concerns with the sweat and impact, So we were considering this in like our initial stages, and so we're definitely thinking about like making like a waterproof exterior for like things about like sweat, and then I think for now we do have some sort of like protective like soft case around it so it doesn't interfere with like other players and the safety of the game. But I think we'll get into more of that with like the policy stuff as well.
Thank you, Krithik. Okay. Another question is, do you anticipate that this will be affordable to all athletes who require one? I think, Christine, do you want to answer that one?
Yeah, I think we're going to consider like the average cost, since like the material right now we're using is more like kind of cheap, and it's more like kind of affordable. And basically involve the electronic system, I think the price is gonna be kind of average.
Yeah. Another question is, how did you meet your outreach partners? Well, being like in the so basically it actually took us a lot of time sending a lot of emails, dozens and dozens of emails out to many people. And we phone called many organizations, and it just so happened that these were the two that were willing to help us. And they've done an amazing job helping us, giving us so much feedback on our prototype, helping us develop our research. So we're really thankful for these outreach partners, and that's how we basically got them, by calling many organizations. Yeah. Another question. In the design process, have you taken the false alarm into consideration? How do you deal with alarm fatigue? I'm not sure what you mean by that. You'll put that in the chat, but
I can take that question. I think if I'm interpreting this correctly, you're talking about if the vibration is accidentally triggered without the trigger device being pressed. And yeah, that is actually one of our top considerations, because again, we don't want to negatively impact the like the game and the ability. So for that, that's more of a matter in the program. The way we program it is that unless it's absolutely getting a signal from the electronic whistle, then it won't trigger. And there'll also be like a fail-safe to make sure that, for example, like if the battery runs out or if it loses connection with the wireless transmission, it won't do anything weird. It'll just completely stop, because again, it's better for it to not be working than to be triggering at the wrong times. Yeah, so we have considered that.
Great. Another question. Who do you think your prime buying audience will be? Coaches, owners, general managers, leagues? So Harini, do you want to take that?
Sure. So currently we're focusing on having our prototype work. We're not sure exactly how we would go about mass manufacturing it, but in the case that we do, the intended audience would probably be coaches, as well as players or entire teams who wish to use this device.
Mostly targeting it through everyone. So yeah, basically. Okay, and just one of the last questions. So is there a need for the deaf players to communicate with one another to call out plays, or in certain sports? Have you had some ideas on how to implement that? Karina, do you want to take that?
Sorry, could you repeat that? I think it kind of.
Yeah, sure. Is there a need for the deaf players to communicate with one another to call out plays, or in certain sports? Have you had some ideas on how to implement that?
Mm-hmm. So this is actually a feature we're considering in our early research stage. But we actually found that when we're like interviewing the deaf community and kind of asking, we actually kind of realized that a lot of the teammates already are like pretty in sync with each other, and it's actually not as much of a problem being like the teammates being able to communicate with each other in play, because they already have like hand signals to do plays. They kind of have that like teammate connection. So while this could potentially pose a problem for some teams, like with the players being able to communicate to each other, we didn't prioritize it, and we instead focused our design more on a problem that was actually more significant and more of a real world problem, which was that coaches and referees couldn't communicate to their players. So pretty much by outreach and by interviewing people in the community, we kind of identified that this was the bigger problem at stake. Yeah.
Okay, I think that is good. I might have not gotten to everyone's questions, but just for the sake of time, just going through, yeah, some of them. Okay, great. We'll go into the subgroups now.
I would also like to mention when we go into the subgroup presentations, which is say like the more focused presentations on parts of our device, we will have Q&A for each of those sections. So that's another chance for those who didn't get their questions answered that we can give them another shot.
Okay. First off, thank you everyone for your wonderful questions. Next, we will have our subgroups go more in depth about these specific aspects of our project. There will be a short question and answers session between each presentation, so keep those questions and comments coming.
Hi everyone, my name is Rachel and I will be talking about the trigger device development and the wireless transmission method that we use for our project. So this is our current prototype of the trigger device, and it will activate the ERM vibration motor on the haptic wearable device when the button is pressed. And the full demonstration of the system was previously shown in the main presentation. So our short-term goal for our trigger device is to integrate an additional button within the electronic whistle. And this could be on top of the button that is on the electronic whistle or underneath the button. And as we are working towards our goal, we developed our current prototype, which has a costume buzzer instead of using a regular electronic whistle. And the costume buzzer will make a noise when the button is pressed. So in our early stage of trigger device development, we started with a switch to activate the vibration motor. And then we move on to wireless transmission method, which we use Bluetooth. And on the picture on the right, you can see that we connect the Bluetooth module to a vibration motor and a phone app. And the phone app will activate the vibration motor. However, and we tested the range of this prototype, which is about 50 meters, and the reaction time that we measured was about 0.96 seconds. However, one of the drawbacks of using Bluetooth is that we are only able to program it to one-to-one transmission. So therefore, we went on research and explore other possibilities of wireless transmission method, including LoRa and Zigbee. So finally, we came to our current transmission method, which we are right now using radio transmission. So this is the system setup of the transmission mechanism. So on the transmitter, we have a nano Arduino connecting to a button, a buzzer, and a radio module. And on the receiver side, we have the radio module and a vibration motor. So when the button on the transmitter is pressed, it sends a signal to the radio module. And the radio module will transmit the signal to the other radio module on the receiver. And when the receiver radio module receives the signal, it will activate the vibration motor. And meanwhile, when the button is pressed, it also sends a current to the buzzer. So the buzzer will be able to make a sound. So in terms of our next step, we will continue to work on develop a more compact version of the trigger device. So we're able to integrate into the existing housing of the electronic whistle. And we already explored different type of multiple to multiple transmission. And currently we are able to use one transmitter to trigger 2 receiver. And our ultimate goal is to trigger 5 receiver at the same time. However, we are open to any suggestion about other possibility that we should use. And in addition, we are working towards to have a direct trigger of our system. This will be achieved by using bandpass. It will allow us to program the bandpass to a specific frequency to trigger the vibration motor on the haptic wearable device. And after this, we are considering to add a coach control. And this will be our second trigger device. And we are happy to hear if anyone have any feedback or suggestion on how we could achieve this goal. In addition, we are also learning to program Lra vibration motor through haptic board. And this will allow us to have different haptic patterns. And we will also be talking about this in the technical group B. So now we will be moving on to Q&A section, and please leave any question, comments, and feedback in the chat.
If you guys don't have any questions, oh, okay. I did get a question. So do you plan to test the durability of the device? Rachel.
Yeah, I will be answering the first question first. Yes, we would test the durability of our device, and this will be tested in later stage of our prototype. And when we have a final prototype with like a more compact version of the trigger device, and also a more compact version of the haptic wearable device, we'll be testing the durability.
Okay, could you also explain haptic patterns?
So by haptic patterns, we means that different vibration pattern. For example, it could be vibrating at a really high speed, or it could be in a certain rhythm or certain patterns. That's what we mean. So because we wanted to have different patterns, so that when we add on a coach control, the athlete would be able to differentiate when who is actually calling for their attention.
And then another question that's come up, how much experience did you have with Arduino and wireless systems before this project?
To be completely honest with you, I don't think a lot of us have any knowledge or experience with we have basic knowledge with Arduino, but we don't really have any knowledge about wireless system before this project. So that's why we're at this learning process, and we are hope to get any feedback.
Okay, does the current wireless connectivity system meet all your needs?
Yes or no. I would say this because currently we are using radio, and radio do allow us to have 5 receiver. However, we currently only develop 2 receivers. But in the future time, we will start to develop more receivers so that all of the players on the team will be able to have one device. But we are happy to look into other suggestion on a wireless transmission method that we should look into that will be more suitable for our project.
Okay. Have you tested if the receiver has trouble receiving signal while the player is in motion?
We haven't at this current stage. However, we will be testing these signal the strength of the signal in the future when we are able to have have our final prototype.
Okay, any other questions? If you have any feedback, or would you recommend any other wireless connectivity systems? Does a modified pre-bought whistle seem more appealing, or a custom one? Is there any feedback, any comments on this subgroup presentation? No.
Okay, so moving on to our next subgroup, which I'll be sharing. So I already introduced myself. My name is Karina, and today I'll be covering technical group B, which is more in depth about our player's wearable device. And I'll take you through the development process and the evolution. All right, so where to start? The first step of making this device was to look into different types of vibration motors. Now, this was important because we want three things. First, we want compactness, of course, because you're going to be wearing it. We want low battery usage so that it lasts the entire game. And we also want a strong vibration, which is perhaps the most important aspect because this determines the device's effectiveness. Our research boiled down to these two types of motors, as you can see in the slides. And I won't bore you with the aspects and like details of each one, but in short, we decided to go with the Lra motor because it has a really strong vibration and so far hasn't caused any battery issues. However, from our research with the Lra motor on the right, this motor is usually found in smartphones and it's actually much harder to program because it takes a different input. And because of this difficulty, we've actually haven't been able to successfully test it yet. Although we still have very high hopes for the Lra motor, so if anyone out there has had experience with it, or programming it, or testing it, please do mention that in the Q&A. The next step for our wearable device was to figure out, well, where are we going to wear this thing? First, we considered the high school sports book policies and found that for the most part, only the wrist and lower arm were prohibited. Second, we physically tested different locations while dribbling a basketball to figure out A, if the wearable would interfere with movement, and B, if that appendage was sensed enough to feel the vibration. And you can see these tests in the rightmost pictures, and that's actually me in the picture. So yeah, after that testing, we concluded that the ankle was the best option. Although, again, if anyone has any other different ideas or experiences or suggestions, please share that also during the Q&A. All right, and next is an evolution of our actual prototype. This is our first prototype, which was more of a proof of concept than anything. You can see there were a lot of wires and electronics sticking out, and this early version also just used Bluetooth instead of our current radio transmission. We compacted the electronics as much as possible after this, and here you can kind of see the stages as we gradually got it a lot smaller. It also helped to switch a few of the electronic components, like the larger Arduino to a smaller Arduino Nano, and directly solder the wires together, and this helped us get the size smaller. In our latest version, we sewed a custom pouch that fits these electronics, and it wraps around your ankle or upper arm using Velcro. Using Velcro was another thing we determined from testing because it was much easier to put on, and also it was better for the electronics instead of trying to like put on like a stretchy armband every time. And this also makes it adjustable, again, like if we're accounting for different sports, like in one sport you might wear it on your arm, or on another sport you might decide it's better to wear it on your ankle. This Velcro allows you to kind of wear it in different positions. All right, and here we have another video demonstration of the prototype in action. This was specifically showing the wearable. See, so if you look closely, you can just barely see the vibration motor vibrating inside the wearable. And also note that the wristband was from a slightly later version, which is why it's slightly different from the latest prototype I showed. All right, now time for Q&A, or not just Q&A, but also if anyone has any suggestions or feedback, that too.
I think there are some questions in the chat already. So if you needed to secure and protect the device, could taping over the receiver impeded transmission? So I'm going to give that to Krithik.
So we actually tested like if obstacles or anything in the way of the transmission would affect it. So like when we were testing it, there is no like effect, like if we had a wall in between or like if there's an object in between the transmission. So we found out that wasn't really a problem.
Okay. You can also take the question, also, has this been tested real time, or are any athletes or teams hearing challenged or not? Basically asking if this has been tested on any athletes or teams.
I can answer this one. So pretty much if you're just talking about athletes, I mean, some of us are athletes, so I mean, when we were testing it, we were like actually dribbling around while testing it. But again, because of the shelter in place, like whole quarantining thing, we've kind of been delayed in being able to test with our outreach partners. Although in March and April, we actually do have some opportunities with our outreach partners coming up to actually test these in a more game-like situation. So yeah, right now we're working with the resources we have to simulate a game as much as possible.
Cool. You also, another question is, you mentioned waiting to learn more about the LRA actuator. Do you perceive that as a better choice for your invention?
I can take it. So I don't think we would perceive that as a better choice currently. However, because we haven't really tested LRA actuator, so we are really looking forward to test the motor and compare the strengths and weaknesses between LRA and ERM.
Yep. And if you have any more questions, put it in the chat. There's some suggestions in the chat as well. And if you have any more feedback, what location you'd prefer to wear the device on, any resources or components, right, and then any insight on programming for the LRA motor, that would be helpful.
And then for all the feedback and suggestions in the chat too, thank you for those. We're taking notes on those too. Thanks.
So now I'm going to basically briefly talk about the communications and research aspect of our team. Some of the background research we started off with was measuring reaction time. Through footage from the game California School for the Deaf versus Mendocino, we found the average reaction time to be about 2 to 3 seconds. This set a benchmark value for us to beat, and our goal is to reduce that reaction time. The NFHS rulebook gave us some guidelines that we would need to keep in mind while testing and creating our project. This also gave us some ideas about the potential location of our device. It told us what locations are permitted, tentative, and prohibited. Also, the ADA can override some of these rules. The ADA is the American Disabilities Act. So we needed to keep this in mind while creating our prototype, as well as when iterating it. We work with 2 outreach partners, as mentioned in the main presentation. We work with Deaf Camp Pacifica and the California School for the Deaf in Fremont. Ms. Ayers is from the California School for the Deaf in Fremont, and she coaches many sports teams at her school, basketball being one of them. We recently talked to Mr. Bella, and he is also a coach at this school. Ms. Martinez is from the Deaf Camp Pacifica, or the California Lions Camp, and she is a coach there, but also she is a deaf athlete. So this gave us experiences from a hearing coach, a deaf coach, and as well as an athlete. And it gave us many different perspectives while creating our device. And it really helped us expand our research. So from our outreach partners, we got a lot of information to expand our research as well as to help us during the developing stages of our prototype. So from our interviews, they basically told us that what they would do to help get the attention of these deaf athletes was by switching on and off the lights, waving something sometimes, and even stomping on the floor to cause a slight vibration. So our outreach partners leaned us towards having the device be worn on the ankle. And this is because it would help avoid damage, but it's also the most preferred. This device can also be covered by a sock when it's worn on the ankle. So we concluded that the other locations might have too much contact or would need to be free during the game. For example, like the arm would need to be free to shoot. Now, in terms of visual versus haptic, they told us that the deaf players are very sensitive to feeling, and it would be the best to stick to this one sense, namely a haptic vibration. Also, it was suggested that a light might be too distracting, and if we were planning to have the device be worn on the ankle, it would not be seen. Now, in terms of our team communication, we are trying our best to communicate with each other, despite our team being 100% virtual. We're using virtual apps like Zoom, Hangouts, and email to collaborate. We're also sharing our work with our teammates through Google Drive, so we can all be on the same page. Hopefully, with the vaccine coming out, we will be able to transition to an in-person meeting soon. Now, in terms of next steps, we hope to test our prototype with our outreach partners by around late March or early April. We hope to get feedback from them about our device, and we hope to measure those results that are beating the reaction time of about 2 to 3 seconds. As mentioned in the main presentation, with our first full prototype, we conducted about 10 trials, and the average reaction time was about 0.62 seconds. So we hope that the results will be somewhat similar or better. And we also want to know if the haptic device was really the most effective, or should visual aids be added in. This will also help us determine if the location of the device should be on the ankle or the location should be somewhere else, maybe the arm or the chest. Now it's time for Q&A, questions, comments, feedback.
Yeah, feel free to put feedback in the chat, especially if you have any comments about our testing methods, any suggestions for virtual collaboration platforms, and especially if you know anyone that's involved with or has connections with the deaf community.
So
oh,
go ahead, sorry.
Oh yeah, so we do have a question from Lay. Have any of you played against deaf athletes? So I think, Karina, you can take that question.
Yeah, so actually I I did have some experience playing against California School for the Deaf when I was in elementary school. I think that was part of what led our team to choose this particular community problem. So yeah, I do have experience. That was just once though when I was in elementary school. That more influenced the topic of our project.
And this is also adding on to another question. What inspired or triggered the original idea in the first place? This was one of the ideas that triggered it because we had this passion for helping people, building things, and also we all had so much like sports backgrounds as well, and so these shared passions basically brought us to create this device.
We have another question. It's, would you ever consider making the device waterproof for swim needs? And I think I can take this question. So currently we haven't considered creating our device for the purposes of swimming, but in that case, then yes, it would have to be waterproof. We have another question. What types of devices are used for deaf athletes in high-level events like Special Olympics? I think, Rachel, do you want to take this question?
Would you mind repeating the question?
What types of devices are used for deaf athletes in high-level events like Special Olympics? I think you or Bridget would be able to answer.
Okay, so I don't think currently there are any exterior device that is currently being used. However, we are hoping to integrate some of our invention into the future games if possible.
Okay, thanks. I think that's all the questions we have. Okay, no, there's another question. A question from Dave. Have your outreach partners expressed interest in leveling the playing field by having the non-deaf team also play using this device with no audible whistle? Isha, do you want to take this question?
Am I able to see that? Oh, okay, sorry. So the question, so basically, yes, we have expressed like interest in this. They have expressed interest in like, yeah, basically just yes. Another question, have you reached out to organizations like the Challenge Athletes Foundation? No, we haven't. We're mostly just sticking to these organizations for now, but yeah, that's really helpful. We'll keep that in mind.
Sorry, yeah, we will consider reaching out to those organizations, and our outreach partners actually have not expressed interest in that, but yeah, or we have another question, are other companies that make devices for adaptive sports? If you do know the names of such companies or organizations, please put them in the chat. We are taking notes on these suggestions and they're very helpful to us, so thank you for them.
Okay, so if that's all for questions for now, then let's move on to the next subgroup, which is sustainability and finance.
So hi everyone, my name is Christine and I'll be presenting our sustainable design, which focuses on the material and manufacturing method and also about our financial tracking so far. So first of all, a brief introduction of our school resources. Our school has like multiple manufacturing tools like 3D printer, laser cutter, and CNC mill machine. So we will most likely develop our prototype using those resources later on. So our device will be designed for disassembly, meaning that all the components are easily disassembled for recycling or repairing, which reduces its environmental impact. And design for disassembly can also save our time on manufacturing stage while reducing the amount of waste. And it also allows us to make future improvements on individual components instead of creating or throwing away the entire product over time. So as you know from the main presentation, our device involves an electronic system. So it is essential to choose an appropriate battery. So we researched some common batteries for wearable devices and compared their properties, uses, and environmental impacts. The chart above shows that lithium-ion polymer is a better choice so far, since it is a lightweight battery with a low environmental impact and higher safety. And for material selection, we consider use wood or acrylic for trigger device, since wood is a more renewable and sustainable material with a low carbon footprint, but acrylic has more aesthetic appearance. So although it is hard to recycle, it's easier to reuse somehow. Therefore, we haven't decided like which material we're gonna use for the final product. And for a wearable device, we currently use Velcro and felt. Since the felt that is made of natural fiber like wool is renewable and degradable. On the other hand, Velcro is made of nylon and which is recyclable. So currently our remaining funds to be spent is about $5,254. And the main spending was on the electronic components. So in the future, we plan to use about like $2,000 more this year. And the remaining funds will be used for future development on our product next year. And also to answer the previous question, like how the COVID changed our budget, I don't really get it. Sorry about that. So basically, due to the COVID, we definitely waste some money, like that is not unnecessary. I think so we can't really test things together, so we basically need to buy material individually for testing. And since we have like some level of communication, so the budget is still under our control, as you can see from the chat. So yeah. Yeah, so thank you for listening. Please type any questions, feedback, or comment into the chat.
Okay, so we have a question and it's, is our idea patentable? So this is a good question. We did have to research patents when we were creating our final application. And there were a few patents with sort of similar systems. So at this point, we're looking into it. I think it could be patentable, but we're not entirely sure just yet.
Just to quickly add on, yes, there are existing patents that is similar to our idea. However, our system will be slightly different, and it also utilize a different method because we are considering using electronic whistle, so it could potentially be patentable.
Yeah, so likely patentable. And the next question from Andrew Wang, what is our approximate timeline? So I'll give this question to Varshini.
So we are planning to finish a good working prototype of this our invention by June or approximately July of the coming year. We started last year during summer, and we're approximately going to finish at that same time during this next year.
I'll just wait another minute if anyone has any questions or feedback. All right, to add on to our timeline, we also do plan to do user testing in March and April, and we do have the Eureka Fest in June, which is the end of grant sort of festival where we will be presenting our completed prototype. We have another question. Do we hope to work on this next year too? So yeah, the QLS InvenTeam is considering, even after the grant ends, to continue working on the project. And we do hope to continue improving our prototype.
Okay, so since I think that's all for our subgroup presentations, I think if we're done with questions here, we can have a second Q&A for anyone who didn't quite get their questions answered, just about any topic. If you would like to put those in the chat now, or if there's any like last minute feedback you need, we can have like a kind of second general Q&A.
So we have a question from Tony. What do we anticipate as our biggest challenges this spring? I think Rachel could take this question.
Yes, no problem. So I would think I would split this question to two parts. First would be triggered part. I think one of the biggest challenge it would be have a really stable connection and have all of the trigger mechanism work the way that we hope it would. And second part would be the haptic wearable device. We would like to develop our final haptic wearable device that is really compact and can be worn on the players by the end of the March, so that we are able to have the actual user to test our product. And just to add on what I just said really quickly, and another challenge would be adding the trigger device into the existing electronic whistle.
Okay, and again, any more questions can still be sent in the chat, but we can move to the final slide. Rini, if you would like to give some closing remarks. I think you're muted. Typical Zoom.
Oh, very sorry. I was muted that time. I did not realize. My bad. Okay, so thank you so much everyone for joining us here today. It was a pleasure to share our project with all of you. Before we leave, please don't forget to fill out our survey. Anyone can fill it out, and your input really helps our project immeasurably. If you want to stay updated, you can follow us on Instagram, or you can check out our website. We have a lot of updates on our website as well as contact information. And that's all for today. Do save the date for June 15th to 17th, which is our final showcase for Eureka Fest.
Hey, do you guys mind if I say a couple of things? This is Candace McGraw. I'm the Senior Director at the Quarry Lane School. I just want to say, wow, impressive job, Cougars. And not just the idea and the device, which are brilliant, but what a professional presentation tonight. These are things that are hard for grown-ups, and you guys have answered these questions live and thought about them, and you've done such a thorough job. So I'm really impressed. I don't know if you even know it, but you are accomplishing a major tenet in the Quarry Lane School mission that is making a difference. So we're so grateful to Lemelson-MIT for this opportunity for you guys to work together as a team, take risks, and through discovery, solve a real world problem. which is really incredible. We're so, so proud of you. I want to say a huge thank you to our passionate, esteemed mentors, Mr. Ong, Ms. Shin, and Ms. Lang. Thank you so much. This is incredible. I'm really looking forward to what's next and how you adapt what you've learned tonight through all the feedback and keep your development. Go Cougars. Thank you.
Well, that concludes our evening, everybody. Thank you so much. Enjoy the rest of your afternoon and evening. Anthony and Genevieve, thank you again for joining us this evening. InvenTeam students, if you can stick around for just a short minute, we'll let everybody else log off. Okay, students, how you feeling? Some smiles. Great job. Listen, if you can stick around for just a minute or two, we have Aaron here from Buzz Engine, who has been a huge help with these events and getting the good word out about what you're doing. And I think he's just got a question or two he'd love to ask some of the students, if you can stick around for that.
Hi, everyone. Good afternoon, evening. As Tony said, my name is Aaron. And before I begin with my questions, congratulations. Very well done. And to echo what Lee said at the very beginning, truly an invention that this world needs. And you identified an amazing problem. So my congratulations to you. So I've got two questions, and we may use your responses in a video that's compiled at the end of all the new grant technical reviews or at some other point. So with the questions that I ask, I'm going to ask you to repeat the question if you are so inclined to give an answer. So why do you invent, or why do you think inventing is important? And so if you have an answer for that, feel free to say inventing is important, or I invent because. And why do you think other students should get involved in the InvenTeams grant program? Why should they apply next year? And you can say in response, you know, I love InvenTeams and other students should get involved because. Okay, so why invent? Why get involved with InvenTeams? Who wants to go first? Any thoughts? It's not a test, I promise.
I'll go first.
Yes, please.
So I think the reason that I invent is because that I would like to help other people with our invention, and that's really a really big part that why I am interested in inventing and designing. And for the second question, would you mind repeating it?
Not a problem. Why should other students get involved in the InvenTeams program? What words of advice would you have for them? Why should they apply for the grant?
Okay, so I think the Lemelson-MIT InvenTeam program is really a great opportunity for students to really wanted to invent, to get involved with inventing. And it's also a really good opportunity for us to learn about really how to reach out to other people and to get our resources and to understand what we need in order to make a successful invention.
Rachel, thank you so much. That was incredibly inspiring. Really appreciate that. And thank you again for being part of this program. Would anyone else like to make a comment?
I can give it a shot, yeah.
Yeah, sure, that'd be great. Thank you.
Yeah, so I mean, what inventing means to me, I think it's something amazing because building an invention is something that can apply to the real world and to like help actual real communities, because it's unlike anything you can get in like school classes. It's unlike, you know, anything you can get in a robotics team. This is like actually something where you get experience solving a problem that's actually applied to real people and applied to the real world. And I feel like that's what makes it so unique, and also kind of made me so interested in the program, because like, wow, like, you know, where do you get this experience elsewhere? Like, when can you do it? Like in other situations. And it's also not just getting the experience of making a real invention. It's also like kind of getting like close with a team. Like, you know, even just this InvenTeams, like, even though we're virtual, I feel like it's been like such an amazing like process, and like, you know, learning together and kind of exploring new territory, you know, just being able to share this experience together and knowing that it actually benefits other people as well.
Wow, awesome. Thank you. Really appreciate that. Anyone else before we let you go?
I can try.
Yeah.
Okay. I invent because I believe that in such a world where there are so many opportunities available, no one should not be allowed to pursue their dream. And I believe that MIT gives all students, regardless of race, their income, their economical level, their struggles, everyone is given a fair chance to access these resources, these amazing resources, to actually create an invention and actually help people. And I think that other people should definitely join InvenTeams, because working together, it truly fuels you in such times of, you know, darkness and sadness. My team was really there to support me, and, you know, it was such a great process just getting to know everyone. It was also, I also took comfort in the fact that I was contributing a little bit to the world and helping make it a better place bit by bit. And I think that everyone can find solace in that.
Wow, that was great. Thank you so much. I do appreciate that. Well, I want to give everyone the opportunity to say something if they wish. All right, Tony, I think that's a wrap then.
Okay.
Thanks everyone for